My name is Liad. Welcome back to my bit manipulation series. Today I will discuss about how can we check that if the ith bit of a number is set or not. So the problem is you are given an integer number n that you have to check the ith bit of the number in binary representation is set or not. So for that we have to see the numbers at first at the bit level, right? So see the numbers at the bit level. So this is the binary representation of 22, 1 0 1 1 0. Suppose firstly we have to check the for the second bit which is 0 based indexing. So the second bit will be 0 1 2 this index, right? So this bit is set, you can see set means this bit is 1. So we have to check that if this 1 or not. Okay, so firstly for that we will take an integer 1. This is the binary representation of 1, right? Then we will move this bit. This 1 have only one set bit, right? 1 to the rightmost position. We will move this one to the expected position that we want to check. In that position the bit is set or not. So this is the second position, right? 0 based second position. So the second position will be this. So we will move this one to this position. For that we have to left shift. We have to left shift this integer by 2 bits, right? So we will left shift this by 2. This will be f left shift 2. So then the binary representation of f will be this. Then what we will do is that we will do AND operation of these two numbers. Okay, so what AND operation does? AND operation does is that if the both bits are 1, then result gives the AND operation 1, otherwise it gives 0, right? So you can see these f left shift 2 only have 1 in our expected position, right? So without this position it is sure that all other position will be 0. So then whatever the value we have in this integer of all other positions, it will give the result 0, right? Because in f left shift 2 these positions are already 0, right? So in this position, in our expected position that we will check in that position if the bit is set or not, in this position we have 1. So if this bit in this position is 1, that means if in this position that bit is set, then this AND operation will give us in this position 1, right? So otherwise if this is 0 then it will give 0, then the whole result will be 0, right? So it means that if the AND operation of these two numbers is 0, then the bit is not set, otherwise it is set. Okay, so this is not 0, this means that it is set. Okay, we can check for the same number for the sixth bit. Okay, so this number only contains the left one is at the 0 1 2 3 4 0 1 2 3 4 fourth index, right? So if this is integer type data, the then it will be 32 bits, right? So I have just seen first 8 bit, you can see this is 3 and 5 8 bit. We don't need any more bits because we have to check for the sixth bit, right? And then what we will do is that we have to check for the sixth bit. We have to make the position of this f in our expected position, which is 6, right? So initially this was in this position, this bit, this set bit was in this position. Then we will move this set bit to our expected position, which is 6. For that we have to left shift this time, which is f left shift 6. Okay, So then this set bit will be in that position. Then we will do again AND operation. So in that case, in this position we have 1 and the other position 0, so it will give 0. These positions will give 0, whatever the value in this position in that integer, it it doesn't matter, right? If the bit is not set in this position, this means it is 0, then the AND operation will give 0 in this position, right? Otherwise it will give 1. So if it gives 0, then the whole bits will be 0. So in this case this is 0, you can see. So this means that this bit is not set. Otherwise if this is not 0, then it means that this bit is set. Okay, so in this case the bit is not set. Okay, let's see the implementation of the checking bit. So first of all, take some queries. Okay, in this query, uh, take some numbers, then and the kth bit, suppose we have to check, receives this number. Then we will check that if the AND operation of n and 1 left shift k, this is not 0, then it will be set, right? If this is not 0, then it will set. Then I will print yes. Okay, otherwise I will print no. Okay, let's check. Okay, let's have some queries, these many queries. So suppose take a number, suppose 13. Okay, so we have to check for the first bit, suppose, which is 0th bit. So it is set, we know that in 13 the 0th bit is set, right? Okay, we are giving another number 4. Let's check if the second bit of this number is set or not. You can see this is set. We know that 2 to the power 2 equals 4. Then let's see for another number 5. So let's check for this number second bit is set or not. So this is also set, we know. Now let's check for some no operation. So let's see the 5 again, and for first bit we check, this is no, right? Okay, then suppose we have 13, we want to check for the first bit again. Okay, this is no, right? So these are all perfect. So this was all for today. Till the next video drops, keep practicing, and thank you for watching.